Video, I'm demonstrating the math lab simulation of a battery charging circuit from the solar array, using buck converter, with MPPT incorporated. This is the charging circuit that I'm going to simulate now. A buck converter is used, with a battery connected at the output terminal. The battery charging current is decided by the MPPT. Here I use the perturb and observe based MPPT algorithm. Now I will tell you, how did I calculate the inductance and capacitance values of the buck converter. But before that, let me give you the specification of the converter. The rated power of the solar array is 210 watts. The solar input voltage range is from 28 to 36. Battery voltage is 12 volt. Switching frequency is 5 kHz. Current ripple is 10%. Voltage ripple is 1%. Output current is given by rated power divided by the output voltage. That is 210 divided by 12 volt. That is 17.5 ampere. Therefore current ripple is 10% of 17.5 amperes. That is 1.75 ampere. Voltage ripple is 1% of 12 volt. That is 0.12 volt. The value of inductance is given by L is equal to V output into V input minus V output, all divided by FSW into current ripple into V input. That is, L is equal to 12 into 28 minus 12, all divided by 5000 into 1.75 into 28. That is 0.783 millihenry. Value of capacitance is given by C is equal to I ripple divided by 8 into FSW into V ripple. That is, C is equal to 1.75 divided by 8 into 5000 into 0.12. That is 364 microfarad. So, this completes the design of buck converter. The equations to find the inductance and capacitance was taken from the textbook Power Electronics by Muhammad H. Rashid. Now we open the math lab and start doing the simulation. First, add a solar PV array. Set the series and parallel string numbers. This is the voltage, current and power curve of the array. This is the MPP voltage and power at 1000 irradiation. This is at 500 irradiation. And this is at 100 irradiation. This is the open circuit voltage of the array. And this is the operating voltage range. Here you need to check this box. Now add a constant block.
Set irradiation 1000.
Set temperature 25 degree. Add a series RLC branch. This is the input bus capacitor.
Set its value 1000 microfarad.
And series resistance 1 milliohms. Now add a MOSFET. Add a diode. Add a series RLC branch. This is the filter inductor, and set its value 0.783 millihenry. This is the filter capacitor, and set its value 364 microfarad. Now add a battery. You need to flip the battery left-right. Enter the battery parameters. I'm using 12 volt, 100 Ah, lead acid battery. Keep battery SOC at 45% and response time 1 second. Check this box. Now add a bus selector. Add battery voltage, current and SOC into the bus. Add a display. Add another bus selector and connect it to the PV array. Add PV voltage and current into the bus. Add a unit delay block. Set sample time 1e rise to -4. This is the MATLAB function block with MPPT code. I have already explained in detail how did I write this code in one of my previous video. So you can check out that to understand more about it. I will leave the link in the description. Now I will just open this block and show you the code. In case if you want, you can pause the video and try to write the code yourself by looking at each line. So, I will just scroll down till the end of the code. Now add a relational operator. Add a repeating sequence. I'm using 5 kHz sawtooth signal as the carrier for PWM generation. Now finally, connect the output of the comparator to the gate terminal of MOSFET. Add a product block. Add a display. Solar output power will get displayed here. Open model configuration parameters. Set the solver type. Add a power guide block. Set simulation type discrete and sampling time 1e rise to -6. Set simulation runtime 1 second. Now I will run the simulation. Here you can see the power. The MPP power level is 213 watts for 1000 irradiation. So, let's see if it reaches that value. Here you can see the battery charging current. Now you can clearly see that the power has reached the MPP level. Now I will increase the simulation time, and run it again. I will try to change the irradiation level and see how it responds. First let's wait till it reaches the MPP level. I'm changing the irradiation to 800.
Since I reduced the irradiation,
The power has come down.
similarly,
The battery current also come down. Now I will change to 500. The power has come even further down.
similarly,
The battery current also. Now I will change to 300. Correspondingly, the power has also reduced. And the battery current also.
So,
This is how we charge the battery from solar, using buck converter.